Hello, my name is Tim Mattson. I'm a senior principal engineer at Intel, and today I'd like to talk to you about a construct that I don't think gets anywhere near the attention it deserves. It's the lovely loop construct. I work at a corporation, so I always have to show a disclaimer, but the real disclaimer that matters is this one. These are my views, not my employer's, not the OpenMP Architecture Review Board's, and I will make some very opinionated statements here, so they're mine. If I say something really smart or worthwhile, it comes from people I work with, and something stupid is my own fault. And I work in a research organization, which is a great job, because I get to just do academic research in a corporate, with all the benefits of a corporate world. But because I'm in a research organization, I'm not saying anything about Intel products. So all of those preliminaries out of the way, let me talk about the lovely loop construct. And to set the stage, I want to talk about the semantics in OpenMP. When we talk about OpenMP, we consider it explicit. It is an explicit representation of the parallel execution. And this is wonderful because basically with the OpenMP directives, you tell the system just what you want it to do. You are in control. The directives are explicit. You control the number of threads that you're requesting, how loops are distributed between threads. You can control affinity and much more. And as you know, control is a really good thing when you want to get the most from a particular system. And so you can write delightful constructs like you see right here on this page. Isn't this great? No, it kind of sucks. I mean, there's a place for being explicit, but what you end up with is directives that are really complicated, really hard to understand, really hard to learn, that in some cases force you to know way too much about the hardware. There are many times when you just want to tell the system what you want done, not how to do it. And while control of exactly how things run on the system is a good thing when you're optimizing for a particular system, when you're trying to write code that's portable across systems, it's a bad thing. It'd be much better if you just declared, this is what I want to get done, and you left it to the compiler and the runtime to figure it all out. Now, if you think this is bad for multithreading, when you go to a GPU, it gets ugly. So here's the standard way we've been doing GPU programming. Really just focus on those two pragmas. Now, you always have to talk about how you're going to map data between the host and the device. There's no getting around that. And so, pragma OMP target map, it's not too bad. Map says if it's to from, it just says copy onto the device at the beginning of the target construct. And when the construct's done, if it's to from, map them back. So it's pretty straightforward. But now look at the construct I have to use to tell the system to take the following loop and map it onto the device, the GPU. Pragma, OMP, teams, distribute, parallel, for, SIMD. What do each of those mean? What does teams mean? What does distribute apply to? What am I distributing? Teams of threads or loop iterations? And if I'm distributing loop iterations, why do I need that parallel for? And when do I need the SIMD and when do I not need the SIMD? We refer to this as the big ugly directive because it is a nice acronym, BUD, which lets us use that old beer slogan, this bud's for you. And we did that because what we used to tell programmers to do, since I've been teaching people how to program your GPU with OpenMP for many years now, you just said, look, you used to use Pragma OMP parallel for, now use Pragma OMP target, teams, distribute, parallel for, SIMD. Ugh. Fortunately, in OpenMP 5.0, we added what I think can properly be called OpenMP's first declarative construct. It's called the loop construct. And it's declarative. It doesn't say anything whatsoever about how the compiler should parallelize the loop. You just put pragma OMP loop in front of the loop, and leave it to the runtime and the compilers to do the rest. Now you have to make promises. There is a promise that you, the programmer, make when you put that loop construct in front of a loop. You're saying that the loops can run in any order. Okay, so that means technically, if you want to get into the jargon, that means the loop iterations are completely concurrent with respect to each other. You also promise the compiler that the region associated with that loop, and remember in OpenMP, region means the code you see in the compilation context with the construct in the lexical scope, but the region also says plus the code of it inside any functions you call. So you're saying when you use the loop construct that the region does not contain any OpenMP directives or runtime library routines. So it's just simple executing loop body. And it looks like this. I mean, isn't this cool? You still have to define data mapping. There's just no shortcuts around that. But I no longer need the bud. I just go pragma OMP loop. And we have been using this on every compiler I can get my hands on. And it works beautifully for parallelizing code on a GPU. So you just figure out where the data needs to go with target map constructs, and then you put pragma OMP loop. I can put collapse, I can put other clauses you're used to putting on the for construct. So I can put collapse 2 if I want to have a two-dimensional index space on the GPU. So I can put the clauses you'd expect with loop-based programming. But the core construct, pragma OMP loop, it's there. It's that simple, and it's declarative. Now, as best I can tell, the loop construct doesn't get very heavily used. And I hope to change that. I hope this video really makes a big push to change that. The problem is the behavior of the loop construct is really, really difficult. I'm going to go further and say, if you're not a compiler writer, it's almost impossible to understand what the loop construct does from the text of the specification. This is a major, major gripe I have with the text of the OpenMP specifications these days. Back in the old days, we used to write them so that an application programmer could read the spec and understand what to do. They made the strategic decision a while back that the spec is for the implementer, not the application programmer. So now application programmers practically can't read the spec. And in particular with the loop construct, it tells you what I just said, and then it says that then the concurrent iterations are executed by the encountering thread. Period. That's it. All right, so the target construct, for example, creates a single initial thread that runs on the device, and it says the concurrent iterations will be executed by the encountering thread. So that means for target, there is one thread, nothing parallel. Why the hell would I use this stupid loop construct? And it's funny because I challenged members of the OpenMP language committee on this point. And I know I'm not going to name their names, so I don't want to cause any arguments here. But their answer was like, "Well, dude, it's the as-if rule." And I'm like, "What the hell is the as-if rule?" They says, "Oh, there's a wiki page on it." So sure enough, I went and dug in, and the as-if rule is something that I guess any compiler writer knows. Any compiler writer would assume, and it basically says that a compiler during optimization can make any transformations it wants to in code, as long as the transformed code does not lead to any changes in the observed behavior of the program. So because of the as-if rule, that initial thread on the device can fork a league of teams. It can, map those teams onto the compute units. It can run the threads in parallel on the compute units of the GPU. All of that can happen and does happen. My problem is the spec never actually says that. And in my opinion, the spec as written leads you to believe none of that can happen because they are executed by the encountering thread. So, I'm going to continue to gripe until they stop writing specs that application programmers can't read. Fortunately, I've dug through and I've worked it all out, and I'm telling you, the loop construct works. It's lovely, and it makes it really, really easy to just declare take this loop, run it in parallel in the GPU. So that's it. It's declarative. You just tell it what you want done, not how. And this is much more portable. So it should run, seamlessly as you move around from one system to the next. So it's portable. In my opinion, it's essential for GPU programming. I mean, just look at it. This bud's for you. Yeah. Pragma, OMP, Teams, Distribute, Parallel, Forest, SIMD. It can take me 20 minutes just to tell you what each one of those things does. So in terms of teaching GPU programming with OpenMP, and if we're really going to, compete among the multiple ways to program GPUs out there, I like much better Pragma OMP loop. So thank you very much.